Have you ever wondered about the leaves falling off from the trees? Or no matter which way a ball is thrown, it will eventually fall back to the ground. Whether I throw it upwards, downwards, to the left, or to the right, backwards, to the front, or diagonally, it will still fall back to the ground. And it doesn't matter if the ball is heavy, like a bowling ball, or light, like a ping pong ball. Hello everyone, I'm teacher Nina, and today we are going to learn about gravity of Earth. You can refer to your Science Year 4 textbook, page 156. Are you ready? Let's go! Now, why do objects fall back to the ground? Okay, everyone, I am now going to introduce to you to an amazing force that we're all experiencing right now without even trying. And that force is known as gravitational pull on Earth. Gravitational pull on Earth, or gravity, is a pulling force that pulls everything around us towards the center of the Earth. Gravity holds objects on Earth to the ground so that we will not float. Whee! The Earth is round, and at the top and bottom there's the North Pole and also the South Pole, where we can find polar bears and penguins. And then we can also find Mount Fuji in Hollywood at the Northern Hemisphere. Kangaroos and koala bears mostly in the Southern Hemisphere. And Malaysia is somewhere near the equator, and so is Brazil. Um, there are also other living things like trees and non-living things like houses, offices. All of these objects, living things or non-living things, everywhere on Earth remain where they are because of gravity. Even aeroplanes that fly in the sky, or ships that sail in the seas, and also icebergs that float in the water. We will never slip and fell off from the Earth thanks to gravity. Now, let's discuss on the HOTS question at the bottom of the page 156 of your textbook. How does an astronaut live in space without the presence of gravitational pull? Explain. Okay, everyone, now let's have a look. Aha! This picture of an astronaut in space explains it all. The astronaut is wearing a special suit. The suit is weighted so that the astronaut will not float away easily, and it also has some thrusts that the astronaut can use to move forward or to stop himself. And there are also other tools around the astronaut on the suit itself, and the suit also has a cooling mechanism inside it so that the astronaut would not feel really hot, because it can be quite warm in there. So that is how astronauts live in space without the presence of gravitational pull, because it is out of the earth, so there is no gravitational pull outside of the earth. Okay, now I would like to introduce to you one more thing. This is the ISS, or the International Space Station. Just think of it like an office or like a home or Soho, small office, home office, but it's like a huge office, home office. This space station is where all the astronauts go to after they have done their work in outer space. Just like architects on Earth, they go to the office and sometimes they need to go out to the construction sites and then they need to get back to the office or come back to home. Just like the astronauts, when they have work to do outside of the space station, so they need to put on their astronaut suits and do their work in outer space, and then they need to get back to the International Space Station, or ISS, to wind down or to report back. And these astronauts, they live in the space stations for quite some time because it is an arduous task to even go to outer space. So they will optimize their time there. So in the International Space Station, when they get back to their station, the astronauts can take off their spacesuits and they will not have to wear them inside the ISS. So as you can see, this female astronaut here, her hair is floating up. And these astronauts here, you can see that there is also no gravitational pull inside the ISS. So it's zero gravity there. So how do they live inside ISS? Well, there are special equipments and also mechanisms that they use. For example, the things that we do on Earth here, which we need not we need not to put on a lot of effort. For example, going to sleep. If you're sleepy, you just lie just about anywhere on the bed or on the floor or anywhere on the sofa. You can just lie down and sleep. But astronauts, they can't do that. Imagine if an astronaut wants to sleep inside the ISS or anywhere else without gravity. What will happen? They will float, and without realizing, they might injure themselves. Why? Because they might knock onto the walls or the ceilings of the ISS or knock some machines or any sharp objects. Oh my god. So for astronauts to sleep, they actually need to they need to get inside a sleeping sack and they need to belt themselves in it so that they won't float off sleeping. And what about eating or drinking? They can't drink like us, drinking from a cup, because liquid will also float in zero gravity. So what they can do is they eat and drink from packets. Yeah, it's quite hard actually to think of it. And so there's other stuff that they need to do, like for example going to the toilet, all the simple things that we can do it with ease on Earth, but without gravitational pull, it will be an arduous task. So I can go on and on explaining about it because I like this topic so much, but I would suggest you to Google it up, watch some videos that you can find on YouTube on the life of astronauts in ISS or in outer space. You will be amazed. Don't take my words for it. Just go and search it yourself and watch them. Oh my god, you'll be amazed. Okay, we shall continue. Okay, now let's open to the next page of our science textbook, page 157. Okay, now we are going to do a test. How to test the gravitational pull on Earth. This test is to prove that it actually exists. We don't really see it, the pull, but it's actually there. Okay, now if you look at this page 157, this boy is using a plastic ball. But if you look at the bottom of the page, it says there that the ball can be replaced with other objects. So maybe this is just a suggestion. I would want you to try and change it to a paper plane in case you don't have a ball with you right now. But paper plane, you can just grab any piece of paper, used piece of paper, and you can try and make your own paper plane the best that you can make, the more aerodynamic and symmetrical and everything. But you can do it. I believe in you. So you just need one. You just need one paper plane to do all this test. Okay, now you are going to drop the paper plane from the top of a chair. You just be careful, stand on a chair and just drop it, and then you observe where does your paper plane go. And then next you will drop it from the right side and then from the left side, and you toss it up, and lastly you can throw it to the back. Okay, and then you observe what happens. Okay, this is the table of result that you can draw. And then what do you think would happen if you release the paper plane from the top of a chair? Will it go upward or will it go downward? Yep, I think so too. Well, just about anywhere, wherever you release the paper plane or a ball or a bean bag or whatever on Earth, it will definitely go downwards. Okay, why? The paper plane falls downward no matter where it is released from because of the gravitational pull on Earth. That is what we have been learning, right? Okay, now let's go to the next page, page 158. 158 is another test. This is quite interesting. All you need is a globe. Do you have one with you right now? Well, I do. Okay, so what you can do is you need to find a globe that works, that can spin, and also some adhesive clay. If you look at page 158, the clay is white in color, if I'm not mistaken. There are other colors as well. We have blue tack or the green ones. It looks like clay, but it's actually adhesive. Okay, and then you need to also have models of objects. For example, you can draw cars on paper. Just draw and cut it out. You can draw a car, a plane, maybe a human being, maybe a gorilla, or maybe a fan, whatever that you like. Okay, so and then you need to paste all the models of objects on the globe using the adhesive clay. Use your imagination, use your creativity. You might need some sticks, really small sticks, for example toothpicks. You can use that to make it stand on the globe. And then what you have to do after that is you need to rotate the globe slowly, and observe what happens to the models. Okay, can you imagine it right now? Alright, record your observations. Okay, now, what do you think will happen? What will you observe? Well, all models of the objects that you have used are able to remain in their position on the globe because, oh, this is actually answering the question. Okay, question number one. Why are the models of objects able to remain in the position on the globe? Explain. So all the models of objects are able to remain in their position on the globe because the adhesive clay makes them stay grounded. Okay, for observation, you have to answer from what you see. So you see that the adhesive clay is making all the models remain intact on the globe. So the adhesive clay actually represents the gravitational pull on Earth. Okay, question number two. So what is your conclusion for this activity? The conclusion should be all objects on Earth remain in their position because of the presence of gravitational pull on Earth. So this is how you answer questions if they ever come out in any exam paper. So observation, you observe from what you can see in front of you, and for the conclusion you need to relate it back to the real thing. Okay? Alright, now let's go to the next interesting thing. What are the effects of gravitational pull on Earth? Look at the picture. I think you have a good idea. Okay, gravitational pull on Earth will cause an object to fall down. For example, the fruit falls to the ground. It will not float. Do you know the story about the scientist who found out about gravity, Sir Isaac Newton? Well, if you haven't heard about his story about the apple that fall off from the tree and hit him on the head, I suggest you Google on it. It's really interesting. And the second effect of gravitational pull on Earth is all objects on Earth remain in their positions. So look at the four apples at the bottom of the tree. They remain there. They are not like rolling on and without stopping. They remain there because of gravitational pull on Earth. Yes, that's right. Okay, now if you look at page 158, you are going to go into the importance of gravitational pull on Earth. If you look at that page, there are two pictures. The first situation is the girl. I think she's in her own bedroom. She's playing with her cat, and there's a toy horse there, and also a toy box. I think Jack in a box, right, in there with a spring, and there's also a cupboard. Okay, so this is a normal situation, I would say. And for situation two, oh my god, what is happening? Why is everything floating? Everything is floating there. And look at Jack in the box. I can see even the screws are floating. Right. So the question would be, in both situations, why gravitational pull on Earth is important? Okay, why is it important? So for the first situation, gravitational pull on Earth makes all objects remain in their positions. So the Jack in the box stays up like that if the girl didn't push it down again in the box, and the toy horse also won't move if she didn't pull it or push it. So all objects remain in their position. And for the second situation, gravitational pull on Earth makes all objects do not float in the air. So I really hope you'll remember these two important stuff about the importance of gravitational pull on Earth. Okay. Now we've come to the end of our lesson today. If you look at this very interesting picture, it's a world without gravity. It's very interesting. I won't elaborate it. You can see it for yourself. You can make your own words. So, a task for you to sum up today's lesson. In your own creative way, write down how your world would be without gravity. How would it be if there is no gravitational pull on Earth? Write it down. If you like essays, you can write an essay, you can write a poem, anything. You can just have a list of things that would happen. It's up to you. Okay, go on, do it. Before I leave, there's something for you to think about. Life, besides gravity, nothing should keep you down. With that, I thank you. Goodbye, everyone.